I welcome you back again on numericals on first law and second law. Mainly second law because second law had the force relation, force equal to ma, and that we are going to use with some previous informations. Let's start directly. A body of very simple questions. A body of mass 4 kg is moving with an acceleration of 0.5 meter per second square. Remember the unit of acceleration is meter per second square. Kg is mass. Calculate the force acting on it. The meaning of this question is, suppose there is one object, body means object, its kg is 4 kg, 4 kg that big, and then it is moving with an acceleration. That means its speed is increasing 0.5 every second, 0.5 meter per second, increasing the speed. That way it is moving. Imagine one object in your visualization. That object is moving, increasing the speed every second with 0.5 meter per second. Now what would be the force which has done this to the 4 kg mass so that its speed is increasing like that? Okay, its velocity is increasing like that so that it is accelerating 0.5 meter per second. That is the meaning of this question. Now what we do is very simple. Even if you do not understand the actual meaning of the question, the answer is very simple. Why? Because we have a direct formula which says F is equal to ma. What is F? We do not know. What is m? We know 4 kg. What is a? We know it is 0.5. You look at here SI unit, so no need to change anything. SI unit, meters in second are SI unit, no need to change anything. 4 5s are 20. 0.1 here, so that means F is equal to 2 kg meter per second square. Same thing we write Newton, 2 Newton. So this is the force that is acting on it. Okay. Another question here. A ship of mass 4 into 10 to power 7 kg, this much kg, is pulled, means force applied, by a force of 6 into 10 to the power 5 Newton. Find the acceleration. Also find the velocity of ship after it has covered a distance of 300 meters. Take resistance due to sea water is negligible. The last part is not important because we are not going to consider that. Because in the motion there is some resistance by the water also. It is not that easy to move on the water. Even for the ship, some force will be opposing it, friction. So that we are not going to take into account. Okay. So now how to start? Ship of mass is how much? 4 into 10 to power 7 kg, quite big. Okay, 4 and then 7 zeros. Don't write 7 zeros. It is easy to write like this. It's pulled by a force. Now force is applied to pull this mass. How much? 6 into 10 to power 5 Newton. Both are in SI unit, no change required. Find the acceleration. Very easy. A is equal to F by m. Why? Because F is equal to ma. So that means A will be F by m. So what is this? Force is 6 into 10 to the power 5. From here I wrote in place of F this one. In place of m I'll write this 4 into 10 to the power 6. So now if I cancel them, it will give me 3 by 2 into 10 to the power 5 minus 7. 1.5 into 10 to the power minus 2 meter per second square. This is the acceleration I got here. After that, what is the remaining here? Also find the velocity of the ship after remember this, after it has covered a distance of 300 meters. We'll go to the first chapter where we had some formula. Okay, on the rough side I'll write it here. Those formula we had: v is equal to u plus at, final velocity, initial velocity, acceleration and time. V square minus u square equal to 2as, final velocity, initial velocity, acceleration and distance, and one more, s equal to ut plus half at square. Here distance, initial velocity, time, acceleration, time. So these were the formula we already studied. From here we will use one of them which is required in this question, that is important. Here, find the velocity of the ship after it has covered a distance. That means we are required to find a distance, the velocity. First I'll write distance, how much, acceleration we already know, okay, this much. Distance is 300 meters. So that means I'm not going to use this. Distance is not given. These two are going to be used, one of them. Let me see which I'm going to use. Okay. Look at there in the question, you do not have the time given to you. Have you seen time? Not given time. So this also I'm not going to use because t is not given. But I am given the velocity. Okay. I have to find the velocity, because if I use this, there is no velocity here that I'm going to. After velocity, I'm not going to find here. After velocity means final velocity. That is. So we have to find v equal to what? Right. Now, initially what happened? Ship of mass was not moving. Force made it to move. That means initial velocity was 0. That is important. Okay. That is why this is not used. We wanted this one. After velocity means final velocity. Now let us use this. V square minus u square equal to 2as. What is v square? We do not know. We need to find it. What is u square? 0 square. 2a, I already found it here. 1.5 into 10 to the power minus 2. What is the s? S is 300 meter given in the question. All in SI unit, no need to change anything. V square equal to, multiply them, 1.5 into 2 into 3, what is this going to be? 1.5 into 2 is 3. Okay, 3 into 300. That means it is 900 into 10 to power minus 2. Now, if I find the square root of that, try to find the square root of this part, I'll get v square equal to 9, because 2 zeros, this will be coming down here. If you did not understand, 10 to power minus 2 is written like this. Okay, here it was down means like 9. Whose square is 9? 3's square is 9, isn't it? 9 means velocity is 3 meter per second. So now you understand the whole question. The whole question is like this. The ship was this much kg, force is applied this much, and it was made to move with 3 meter per second. And that velocity change was 0.5 into the acceleration is 1.5 into 10 to power minus 2. Okay, so this is how it was moving. Very little for acceleration, and the, with which it was moving. So this is our answer. 2 of the questions answered. Okay, so you need to remember very simple question, very simple formula. F is equal to ma, and all these are expected to know. V is equal to u plus at, v square minus u square equal to as, and s equal to ut plus half at square. Similar questions will be followed. Okay, I'll just stop here.